Section 9.2, Arithmetic Sequences and Partial Sums. So, sequences and series are functions where you look at consecutive terms, one term to the next. So you look at all those terms as a whole. What gets you from one term to the next? And specifically, arithmetic sequences, kind of what sets them apart. Arithmetic sequences are a sequence where you have a common difference. And that common difference you can kind of think of as the slope in a linear function. What gets you from one term to the next? A common difference is then the difference between two consecutive terms. So like a2 minus a1, a sub 3 minus a sub 2, a sub 4 minus a sub 3. So any two consecutive terms, the later one subtracting the initial one, or the first one, the one that comes before it. And when you have the same difference every time you do those subtractions, you get D, a common difference. So let's look at some examples here, okay? Of how the common difference can be found and how you can identify it. So a sequence whose nth term is 4n plus 3. So whatever term you want, the first, second, and third 58th, plug that number in for n. So the a sub 1 term, 4 times 1 plus 3, and you get 7. A sub 2, when you plug 2 in, 4 times 2 plus 3, and you get 11. A sub 3 term, 4 times 3 plus 3, you get 15. A sub 4, 4 times 4 plus 3, and you get 19. Okay. And you see, from the first to the second, the 7 to 11, we are adding 4. From the 11 to the 15, again adding 4. From 15 to 19, yep, you guessed it, adding 4. When you have this commonality between the terms, that plus 4 is your D value, your common difference, and look at the explicit formula for n plus 4. Again, common difference can kind of be thought of as the slope of these sequences and series. So you have the 4 right there. And if we wanted to get a little more particular about these, you could say common difference, D, is 4, okay? And your first term, a sub 1, we found it as 7. Let's look at another one, okay? So nth term is 7 minus 5n. So let's look at a sub 1, 7 minus 5 times 1, and you get 2. A sub 2, 7 minus 5 times 2, we get negative 3. A sub 3, 7 minus 5 times 3, negative 8. A sub 4, 7 minus 5 times 4. And I'll tell you that I'm not even doing the arithmetic in the formula anymore. As you go through these, just I plug in 1, I plug in 2, plug in 3, plug in 4. But then to calculate the term, I'm just subtracting 5 from the previous term. So to do 7 minus 5 times 3, I'm not in my mind calculating that. I'm just doing negative 3, the a sub 2, taking away another 5. So 7 times 5 minus 4. Mentally I'm not doing 7 minus 20, just taking negative 8 and adding another negative 5 to it. Again, I'm finding that common difference, negative 5, negative 5, negative 5. And then my explicit equation right there, again I have negative 5. So a common difference can be negative, you're just adding the negative value. Common difference, negative 5, a sub 1 is 2. And eventually, this leads us to an explicit formula for an nth term. And this is only for arithmetic sequences. So a sub n, the nth term, whatever you want, take your first term, a sub 1, add 1 less than n times your common difference. Because for your first term, the 2, there's only, for your first term, sorry, got myself a little turned up. Your first term, you're not really adding any common differences. Then your second term, you're adding 1. Your third term, you're adding 2. Your seventh term, you're adding 6 of those common differences. So a formula for the nth term of the arithmetic sequence, whose common difference is 3 and whose first term is 2. Well, we have common difference, which is 3. Our first term, which is 2. So plug that into the formula. First term 2, so a sub 1 is 2, plus n minus 1 times d, which is 3. Alright, so if you know or can find the common difference and the first term, you can create this explicit formula so you can find any term that you want. So if you can find any term you want and all the terms in between the first and that, you could add them up, get the sum of a finite arithmetic series. Now we only do sums of finite from this term to that term, because if you were to find the sum of an arithmetic infinite sequence, you wouldn't really have an answer because you're always adding the same amount. So you're either going towards positive infinity or negative infinity. That's no good, okay? There's an infinity, again, is not a number, it's an idea. So only a sum of finite arithmetic sequences. S sub n is n over 2, the number of terms you're adding up divided by 2 times your first term plus your nth term. Now, like I said in the previous section, your first term may not always be 1. Like here, first term is 1. Here, though, your first term is found by plugging in 0 for n. So be careful with the first term. It's not always plugging in 1. It's whatever your sequence starts at. So take a look at this page and the example on the previous page that I didn't do. Check your work with my completed notes online.